Okay, now the first item we'll be looking into will be over in the textbook in section R4. And this is going to be with regard to working with polynomials. And now for what we have for this particular section, now we'll be looking at multiplying polynomials. And so let me kind of navigate here. It's kind of provide a little bit better view. Sorry about. If anybody has a question to type in, I will have that icon exposed. Okay, just if I needed to pause or anything, if anybody has questions, you can either click on the raise your hand or just type in a question. I will respond. All right, so we have just from the start, okay, we're looking at working with polynomials and operations. And just for the first portion, okay, we have multiplying polynomials, and likely you have seen these in various capacities, and one form being what is referred to as the FOIL method. Okay, and that's acronym for first, outer, inner, and last. And just the general representation of this, okay, with the FOIL method, you can have a couple of two-term expressions in the form of a plus b and c plus d, and having these to multiply out. Okay, so if you go with the general FOIL method, okay, for the quantity of a plus b times the quantity of c plus d, okay, if you go with the traditional route, you're looking at a times c. First terms from each pairing, and then you have the terms most distant from each other with a and d. Inside will be the closest terms from the separate groups. Okay, so you have b times c. And then we have pairing up, okay, the last terms with b times d. Okay, so you have first, outer, inner, and last. And there's also another approach. You may have seen this, and you might have used it more commonly. And this is what's also referred to as the geometric FOIL method. And some refer to this as the box method. And with the geometric FOIL method, say we have with same set of terms. Again, we can set up a bit of a 2x2 matrix. And it doesn't really matter what you have as the row headings or the column headings. We'll just say we have A and plus B as the column headings, and C and plus D as the row headings. But you can have A and plus B alongside, and then have C and plus D at the top. And looking at multiplying the corresponding parts, okay, we have A and C. We have A times C. You have A times positive D, so it'll be a plus AD. You have, for the second column, you have at the top, we have the pairing of B and C. And then we have with the last cell, we're looking at positive B and positive D. We have B times D. Okay, so you have another FOIL arrangement. And we have in terms of the follow through. Okay, so you have AC plus AD plus BC plus BD. Okay, again, the FOIL approach. Okay, and for what we have, just as examples, if you're looking at multiplying polynomials, and we'll see we have in the first case, we'll go with two binomials of addition. And we'll say that we have 3x plus 4 and x plus 7 okay. And if you can work at it, if you've got the abstraction to go ahead and know what the result is going to be, that is fine. But I'm just going to sort of extend this, kind of draw out, okay, some of the in-between intermediate steps. Okay, so you had the first terms, you have 3x and x. You have the outside terms, you have 3x and 7. And we have for the inside, okay, so you got 4 times x. And with the formation of the last product, we have 4 times 7. Okay, so again, first, outer, inner, and last. And multiplying, we have 3x times x. Okay, and 2x's that multiply will come out to x squared. So the first product will be 3x squared. Outside product, we have 3x times 7, so this will be 21x. For the inside product, we have 4 times x. And the last product is going to be 28. Right now we have 4 terms, but I can condense the number of terms present by doing what is regarded as combining like terms. Now the first term is 3x squared, and that is the only term that has x raised to the second power. Now we have 21x followed by 4x, and these are regarded once again as like terms, and they have not only the same letter but also the same power, to which x is raised. So 21x plus 4x, so this will make 25x. Okay, and notice I cannot add 3x squared and 25x together. While both terms have the same letter, they do not have the same degree. If I had x squared alongside 25, I could have combined as 28x squared, but I can't. And then we have 28 to follow. And that is the only standalone constant, that is, number that has no letter attached in the set. Okay, so you have 3x squared, 25x, and 28 will make up the result for multiplying the binomials 3x plus 4 and x plus 7. Now, another case that we have regarding the multiplication of polynomials, and we'll throw in exponents a little bit beforehand. And let's say that if we have 4x minus 3y, in this case the quantity of 4x minus 3y, and we have taken to the second power. Now with the second power, okay, what would this mean in terms of multiplying? And I have seen some make the mistake regarding raising to whatever degree is going to be the multiplication of that expression by the expressed power. But what this too means upon translating in terms of multiplying is going to be referencing the number of appearances of that particular expression. So we have 4x minus 3y to the second. This will mean 4x minus 3y times itself. So it appears twice. Had this been to the third power, it would have been that expression times itself once more. Now, in carrying out what we have regarding the FOIL method, and so just looking at what we have here. So I'm just going to do this kind of step by step, but again, if you're able to attain the products beforehand, that is fine. So with the regular FOIL, okay, so you got 4x times 4x, and we got 4x times, okay, not 3y, but negative 3y. And for the inside, we got negative 3y times 4x. And for the last terms, they have negative 3y times itself. Okay, so for what we have in the case of the products, okay, got 4x times 4x, okay, that is 16x squared. And we have, for the next two terms, you have a positive times a negative, so we have a negative product here. So this would be a negative 12xy. Next in line, we have a negative times a positive, which will make another negative. In this case, we have negative 12. And if I put the letters in alphabetical order, we have xy to follow once again. And then we have a negative times a negative is a positive. Negative 3 times negative 3 is a positive 9. Y times y becomes y squared. And we have a bit of history to repeat. Now we have at the front, we have the only x squared term that exists. Now for what we have in the middle, we're able to combine these terms into one, where they have x and y, and not just x and y, but x and y of the same degree. So you have a negative 12xy and another negative 12xy. So this will become a negative 24xy. And this will be followed by the last term, which we will have as 9y squared. So we have another trinomial or three-term expression to be the result. And now, let's say that for what we have as another case. Now we started out with an example that was involving expressions of addition, followed by that where we had just exclusively the operation of subtraction. If we mix it up, and let's say that if we have the quantity 3x plus 4 times the quantity of x minus 10. Okay. And I'll tell you what, if you've been accustomed to, like, I like to go from here to this stage, or from this stage to going ahead and getting the products, you're welcome to do so. In fact, I think we're going to do it in this particular instance. Okay, so if we look for the first product, now we got 3x times x, 3x times x. Okay, so you have 3x squared. Now for the outside product, now we got a 3x times negative 10. Positive 3x times negative 10. This is going to be a minus 30x. Inside product, you have a positive 4 times x. So this would be plus 4x. And the last product, you have 4 times negative 10. So this is going to be minus 40. Okay, so just restate. So you have first, outer, inner, and last. So So combining, we got 3x squared. In the middle, I have negative 30x plus 4x. So this will amount to negative 26x. And followed by the subtraction of 40. And so we hereby had the result as 3x squared minus 26x minus 40. All right. Now, let's say that in the case of working with expressions, so just for the next few minutes, let's see what we get whenever we multiply. Here's one that has a little bit of a different twist to it. Let's see what we get whenever we multiply 4x plus 3 by the quantity of 4x minus 3. And also, let's see what we get whenever we have the square minus 8z. Yeah, so let's see what we get for these two items, and we'll discuss in a few moments. Okay, for what we have for the first combination, okay, we have almost the exact same expressions. However, we have the addition of 3 at the front, and then we have at the back, we had the subtraction of 3. And looking at multiplying these two-term expressions, okay, so if I FOIL out, okay, so you got 4x times 4x. So the first product will be 16x squared. Now for the outside, okay, we got a positive 4x times negative 3. So this will become a negative 12x. And then we have 3 times 4x, positive 3 times 4x. So this will become a positive 12x. And the last part, we have 3 times negative 3, so this will be negative 9. And for what we have in terms of following through, okay, so you have 16x squared. For the outside and the inside product, okay, outside product is at negative 12x. The inside product is at positive 12x, and negative and positive amounts in the same weight are going to end up canceling each other. So this time around, instead of a three-term expression, we're going to end up with 2 terms, in this case, whereupon we have 16x squared minus 9. And whenever you have almost identical expressions where you have same terms, but one operation is of addition while the other is of subtraction, the resulting product is going to be a case of what we have with a difference of squares. Now for what we have next in line, now we got 3x minus 8z raised to the second. And just rewriting in terms of multiplying, so you have 3x minus 8z times itself. Now we'll carry this out a little bit further. See, if I put this in the framework of the geometric FOIL, okay, so 3x minus 8z. And and looking at what we have in this 2x2 array. Okay, so we have with the corresponding parts here in the upper left hand cell, we have 3x times 3x, so this will become 9x squared. And then we have in the lower left hand section for the outside product, we have 3x times negative 8z, so this will be a negative 24xz. Then we have in the upper right hand section inside product, okay, this will be another negative 24. And placing the letters in alphabetical order, we also have xz. And then we have with the last product, okay, now a negative times a negative is going to be a positive. In this case we have 64. And this will be z squared. And again, just carrying out what we have here. Okay, so we have a FOIL arrangement. The terms don't have to be in that exact order, but here we got 9x squared minus 24xz and another negative 24xz plus 64z squared and we have in terms of the follow through. Okay, so you have 9x squared is the only square in x term that we have. Now negative 24xz and a negative 24xz, okay, these will combine as opposed to canceling. A negative compounded upon another negative is going to be yet another negative that is formed, so you're going to have minus 48. And placing the letters in alphabetical order, we have minus 48xz, and we have plus 64z squared. And whenever you have the square of a binomial like this, you're going to have the resulting product to be what is regarded as a trinomial square. Or a square trinomial. I've seen it both ways. One might ask, okay, did we not see this earlier? And the answer to that question is yes. Well, we saw it whenever we looked at 4x minus 3y to the second Alright, so at this stage we've looked at multiplying expressions to get to a product. Now, putting the gears in reverse, instead of multiplying, you might have the product given beforehand. And one might ask the question, okay, what terms will multiply each other to get to that product? And so we're going from multiplying polynomials to factoring. And so for what we have at this next stage, now I'll start out with some relatively basic examples, okay, where the first term in the mix is going to be x squared. Now let's say if we have factoring the following, and we'll say we have an expression such as x squared plus 7x plus 10. Okay, so if I factor, okay, so with the first term in the trinomial at x squared, okay, that times itself, that will give you x squared will be x. Now in terms of what number or numbers will be used to fill in. Okay, we have 7 and 10 involved. Okay, now where the 10 is concerned in terms of completing, you ask, okay, what numbers will multiply themselves, forming the product of 10, and at the same time add up to the middle coefficient, which is 7. Okay, well, it wouldn't be 1 and 10 or 10 and 1, but since those numbers add up to 11, but for 2 and 5 or 5 and 2, they will add up to 7 while multiplying out to 10. And so for your expressions, and the order does not matter. We say we have x plus 5 times x plus 2, but if you have it in reverse, that also works. For multiplying x plus 5 and x plus 2, or x plus 2 and x plus 5, will result as x squared plus 7x plus 10. Now let's say if we have a case of a difference of squares, where we have x squared minus 64. Notice we do not have an x term in the middle. And for those who are newly acquainted with the difference of squares or haven't seen it in quite some time, okay, you have x squared at the front. Now we're missing a first order x term, but you can regard this as if you had 0x, followed by the subtraction of 64. And looking at factoring, so again, little history repeating. Okay, x squared will go to x and x. For negative 64, okay, now two numbers will go into negative 64, one positive and the other negative. Now we're looking at two numbers that will go into this in terms of multiplying, but will simultaneously add or subtract where the result is 0. So this means that you'll have just as much added as there will be subtracted. So the only number we can plug in to complete each of the addition and the subtraction is going to be 8. So x squared minus 64 would factor out to x plus 8 and x minus 8, or the other way around. Now, just touching upon factoring a square trinomial. Let's say if we have x squared plus 20x plus 100. And it's for a problem like this that Alex will be particular about how the final result will be displayed. For x squared plus 20x plus 100. Again, so we have x squared again, so this will factor out to x and x. And with 100, okay, just like when we factored out 10 to 5 and 2, so that 5 and 2 will add up to 7, we're going to factor out 100 into numbers that will add up to 20. And guess what? The only numbers we'll have will be 10 and 10. And guess what? We have a repeating factor with x plus 10. And this will be how Alex would want this displayed, which I'm about to follow up with. You got x plus 10 times itself. It appears twice. And so just putting this in an exponential display, it will turn out that x squared plus 20x plus 100 will come out to the quantity of x plus 10 raised to the second power. Now, let's say that if we have a trinomial, and we'll say that we have x squared minus 10x minus 24 and if we look at factoring, so we have with x squared, this will go to x and x. Now for negative 24, okay, when factor is going to be a positive and the other is going to be negative. All right. Now, for what I have here, and you had to be careful with how the addition and the subtraction are going to be applied. Now you're looking at two numbers that will multiply into negative 24, but you want the sum or difference of these numbers to amount to negative 10. And so this is going to signal that the weight of the items will be such that again, the sum will be at negative 10. So more weight will be given to the subtracting than to the adding. And so in this case, all right, we'll have only x plus 2 and x minus 12. And you can double check. 2 times negative 12 is negative 24. And if I add 2 and negative 12, that comes out to the middle coefficient, which will be negative 10. And if I have, as another squared trinomial, say I have x squared minus 12x plus 36 and if I factor, so again we have x squared will go to x and x. Notice you have a positive 36 at the end and the middle coefficient is a negative. Okay, so strategy is, okay, so we're looking at two values, or values that will multiply into 36 and at the same time will add up to negative 12. Okay, so for numbers to multiply out to a positive, either both of these individual numbers have to be positive or they both have to be negative. And to add up to a negative, we need the factors to be on the minus side. Okay, and so in this case, for the combination here, okay, that which will add up to negative 12, and let me just mention, okay, it cannot be negative 36 and negative 1, that will add up to negative 37. And it cannot be like negative 2, negative 18, or negative 3 and negative 12. And it cannot be negative 4 and negative 9. Your sum will be at negative 13, almost, but it's not a case of horseshoes and hand grenades. Okay, so we want to get to the exact result, and so it's going to turn out that we're going to have an identity, and the factors will be negative 6 throughout. Negative 6 times negative 6 is 36. Negative 6 plus negative 6 is negative 12. And guess what we have with the repeat of x minus 6? Just like we had with x plus 10 moments ago, x squared minus 12x plus 36 will come out to the quantity of x minus 6 raised to the second power. Right. And now, just looking at what we have in the case of factoring. Just as quick exercises. So let's see what we get for x squared minus 7x minus 18. X squared minus 13x plus 30. Also, let's see what we get for x squared minus 81, just for the next few moments. Okay, tell you what, I think we'll start out with the last of the set. This is probably the quickest one to solve. Here, just like what we have with x squared minus 64, we have a difference of squares with x squared minus 81. And with this arrangement, we'll add and subtract the same amount. So we have for x squared, this will factor out to x and x. And we have x plus and x minus the same amount. And that times itself, which would give you 81, is going to be 9. So we have for x squared minus 81, we have x plus 9 and x minus 9. All right. Now just kind of backpedaling, okay, to what we have with the first item. Again, the first term we have x squared, and all of these expressions are factorable, and x squared will factor out to x and x. And looking at the weights here, so you got a minus 18 for the product, so it'll be a plus factor and a minus factor, and where the combination in terms of adding will amount to -7. More weight will be given to the subtraction than to the addition. So in this case, okay, we're going to have only x plus 2 and x minus 9. Again, 2 times -9 is -18, and 2 plus -9 comes out to -7. So this will be the combination, and I've been asked, something like, is it okay to write it as x minus 9 at the front and then x plus 2 to come thereafter? And the answer is yes. Now for what we have in the case of x squared minus 13x plus 30. Okay, so x squared will factor out to x and x. Then we have for factors of 30 that will add to -13. Okay, so we have to multiply out to a positive and simultaneously add to a negative. Okay, both these factors will have to be negative. And for this combo, okay, we're looking at -10 and also -3. So this will be the combination that we have here. And again, you can also express that as x minus 3 at the front and x minus 10 to follow. All right, now there is another part here where there can be special cases of factoring where the leading term is not necessarily x squared. And let's say that if you have what is going to be referred to as factoring by grouping. And for what we have in the case of factoring by grouping, let's say that if you have as an example, okay, say if we have 3x squared plus 19x plus 20. Okay, and we're looking at factoring by grouping. Okay, and what you're going to do, instead of using the trial and error, okay, if you got 3x squared plus 19x plus 20, what you're going to do in terms of factoring by grouping, you're going to multiply the first and the last coefficients. And here we have 3 times 20 is going to be 60. All right, and one can say, all right, well, you've worked with a 3 and you've worked with a 20, okay, but where does the 19 come in? Okay. Well, this would be in the case of working with the product we just arrived at. Okay, and for the factors of 60, we want those numbers that will multiply into 60 and also add up to 19. Okay, so we just started out with 3 and 20. Now 3 plus 20 is going to be a positive 23. And I'll just make up like another set of numbers. Okay, like 60 is a multiple of 10. If you thought of like 6 and 10, you're closer, a little bit closer to 19, but still no cigar. Okay, so 6 times 10 is 60, but 6 plus 10 comes out to 16. So we need something else. And for that combination, that will add up to 19. While multiplying out to 60, those numbers will be at 4 and 15. 4 times 15 comes out to 60, and 4 plus 15 comes out to 19. And this is a combination we are seeking. And one might ask, okay, well, we got those numbers, but what are we going to do with them? This is going to be the pathway to creating what is going to be factoring by grouping. And with the numbers 4 and 15, there will be variable terms that will arise from splitting up the 19x so you still have at the front, you have 3x squared. And with both 4 and 15, it doesn't matter which one you have at the front. I'm just going to put this as I originally have it. Let's say we had the first x term will be 4x, and 15x will follow. And we have followed by the addition of 20. Now for the grouping, okay, we got two pairs, one pair at the front. And we just put those in parentheses. And notice we have between the first two and the last two terms, we've got the operation of addition. And I'm going to use a little bit of color coding. We've got addition in the middle. And the terms that follow with 15x plus 20, I'll just put these in parentheses. So we're grouping the front pair as well as the second pair. And looking at what we have for 3x squared plus 4x, this is where the factoring will come in. For 3x squared plus 4x, now the highest term that will go into both of these will be at x. And x into 3x squared plus 4x, okay, that is going to be 3x plus 4. And we can bring down the addition. Now for 15x plus 20, okay, now we're not going to have a variable this time since 20 is just a constant. So the greatest common factor is just going to be the highest number that will go into both 15 and 20, and that number is going to be at 5. And taking 5 into 15x plus 20, 5 into 15x is going to be at 3x, and 5 into 20 is going to be at 4. And so we're going to have two factors to result. And the reason I'm using the color coding is that if you notice what I still have in black, you've got 3x plus 4. That is shared in common. And the other factor of this particular trinomial will be formed from, after this arrangement, what I have on the outside. Okay, so we have, and combining, so you have x on the outside, addition as well as 5 on the outside, and clustering those together, it's going to turn out that the factors of 3x squared plus 19x plus 20 will be 3x plus 4 and x plus 5. And I'm just going to mention, I know it's a little bit rushed, or it seems a little bit rushed, but if I had 15x at the front and 4x to follow, and I did the factoring by grouping, the x plus 5 would have been where 3x plus 4 is, and the 3x and the plus 4 would have been on the outside, but you would still get the exact same result.